Oh, hi there. Hello, everyone. My name is Dr. Simon. Welcome to my CC lab. Hi there, girls. What brings you guys here today?
I miss you, Simon.
Me too.
Can you feel my heart beating for you?
What? I bet my heart beats faster for him, JC.
No way! Mine's obviously faster. Mine's faster. Mine's faster.
Crazy. That got me thinking. I wonder if the heart rate of Stacy, which is obese, is higher than the heart rate of JC, which is normal. Let's embark on an experiment to find out. Before I start, let me collect some samples. Okay, I'll need 50 obese people and 50 normal people. How can I collect? Oh, I have an idea! 雷龙啊! Come! Free buffet and free pole dancing lesson for the first 50 people. Come, faster!
Hot dog, hot diggity dog. Now we got ears, it's time for cheers. Hot dog, no problem solved.
They will never know that I'm actually measuring their heart rate as they pass through the sensor. Yes, finally 50 samples. So, according to my research, studies have shown that a 10% increase in body weight increases heart rate, and heart rate will decrease with weight reduction. So, I hypothesize that obese people will have a higher heart rate than normal people. Let's begin!
Firstly, descriptive samples. According to the two samples I have collected, the mean, mode, and median of obese people is 86.2, 80, and 88 respectively, whereas the mean, mode, and median of normal people is 80.58, 81, and 80.5. Whoa! The mean and median of obese people is much higher than normal people, but the mode is almost the same. Okay, let's see the data dispersion. Obese sample has a range of 60, and the normal sample has a range of 57. Standard deviation of the obese is 13.05, while standard deviation of normal is 13.27. The range and the standard deviation for both samples is almost the same. So this means the data dispersion in both samples are almost similar. That's very good. Whoa, what's this? A box and whiskers plot? Cool. Let's compare. What I see is there are no outliers, and the minimum and maximum in both samples are quite similar. But the Q1, Q3, and median of the obese sample are much higher than the normal sample. Comparing the 75th percentile of both data sets, it shows that 75% of data falls under 96 BPM for obese samples and 89 BPM for a normal sample. This further proves that obese people have a higher heart rate than normal people. We are getting close!
Let's analyze the shape of normal and obese graph. The normal sample also has a G-value of 0.37, which means zero skewness, and by looking at the fit line, we can see an evenly distributed data. So it also has a K-value of 0.26, hence zero kurtosis, and the fit line looks like a bell-shaped curve, so this data has a normal distribution. Now let's look at the obese sample. It has a G-value of negative 0.12, and again, with the aid of the fit line, the distribution seems to be normalized. The K-value of the graph is 0.51, and it is also bell-shaped. Since there is zero kurtosis and zero skewness, the obese sample also has a normal distribution.
Since most of our data comparisons show that obese people generally have a higher heart rate than normal people, I, Dr. Simon Tan, will make an intermediate conclusion that obese people have a higher heart rate than normal people.
Moving on to the inferential statistics and hypothesis testing. Our null hypothesis is heart rate of obese people is equal to the heart rate of normal people, while alternate hypothesis is obese people have a higher heart rate than normal people. A type 1 error when null hypothesis is true will indicate that obesity does not affect an individual's heart rate, but I concluded otherwise. This consequence is not as severe as if it's not true. People will just be more cautious about their weight so that they can reduce the heart rates and in turn prevent diseases.
We must lose weight to become healthy.
A type 2 error when null hypothesis is false will indicate that obese people have a higher heart rate, but I concluded that they don't. This consequence is more severe as with this claim, people will not be as concerned about their weight. If the public are not conscious about their weight, their heart rate will increase, leading to an onset of various diseases such as heart attack.
I don't need to care about my weight. La 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 la. I'm still healthy. Let me continue eating. Nom, 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 nom.
Nom 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 nom. Oh, nom 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 nom.
That was so sad. Since committing a type 2 error is more significant than a type 1 error, a higher alpha will increase the power of the test and thus reduce the probability of type 2 error. Therefore, we set our alpha at 5%. To determine the power of our test, let me use some magic. The power is 71.2%. Not too bad, but it's lower than my expectation of 80%.
The type of test we are doing to compare the two samples will be the two independent sample design. This is because of our large sample size n and the two samples given are not related and independent of one another. As the population SD is unknown, I shall perform the F-test on the sample's variance to determine if the variance is equal. And the result is, they are equal. So this means we have to perform hypothesis testing based on case 2. Case 2, where population SD is unknown and equal. My null hypothesis is the difference between the mean heart rate of obese and normal samples is 0, which means no difference. Or my alternative hypothesis is that the difference between the mean heart rate of obese and normal samples is more than 0. Now let's compute the put SD. Put SD equals to 13.1616. Next, the standard error. Standard error equals to 2.63232. Test statistics TS equals to 2.22. From there, the p-value is 0.014. Since p-value is less than alpha of 5%, H0 is rejected. And this indirectly supports my hypothesis. Finally, the experiment is over! So after analyzing the descriptive statistics and performing hypothesis testing, I conclude that obese people have a higher heart rate than normal individuals. See? Told you my heart beats faster for Simone. but you are unhealthy.
That's right. I don't like unhealthy people. Unless you give up your ice cream, I will leave you. Okay?
But I want my ice cream.
Then so long, Stacy. I don't want you anymore. Let's go, my darling JC. Come, let's go.
Oh man, what a jerk.
Hey, pretty girl, want to share my ice cream?